Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika, welcoming you to today's session. In today's session for Module 7 Probability for Grade 10 Advanced, we are going to be understanding the fifth lesson, Probability and the Multiplication Rule. So in this lesson, we will be understanding what are the two types of events, independent and dependent. And once we understand what these events are, we will be trying to find its probability using the multiplication rule. So that's our goal for this lesson. So in today's lesson, the new words would be compound event, independent events, and dependent events. So let's understand what are all of these one by one. So on the screen, you first see the definition of a compound event. A compound event or a composite event consists of two or more simple events. So for example, if you are performing more than one event at the same time, maybe one followed by the other, then that is a combination of two or more simple events. So that's called a compound event. For example, if you look at this example which is given, for example, I have a coin, a dirham coin, and I toss it. So if I toss it one time, my sample space will have one head and one tail. And then followed by it, I roll this spinner that you see. It has three parts: blue, green, red, 1 2 3 number, and any one of the numbers can come. So the sample space can be any one of these three numbers. Now if you remember your second lesson where I teach you the fundamental principle of counting, then I told you that for a compound event which has say two stages or two parts, like this one, two simple events: the first, the tossing of the coin; the second, the moving of the spinner. So in that, to find the total number of possible outcomes, you can draw your list, or you can make your organized table, or you can also do the tree diagram. So to find the number of possible cases, what are the two options for the coin? Two. What are the two options for the spinner? Three. So just multiply. That's your fundamental principle of counting, to calculate the total number of possible outcomes, and it will give you six outcomes. So what are exactly these six outcomes? They are mentioned here. Either the coin can have head or it can have tail, and for each of the head and tail options you have another three options for the spinner. So if I try and draw the tree diagram, first stage, I'm just tossing the coin, so head and tail can come. This is the first stage. At the second level, I'm moving the spinner, so for each of this option I have another three options. Any one of the three numbers can come on the spinner. So if I want to write my options for the sample space, then head followed by 1, that's my first option. Then head followed by 2 on the spinner, that's my second option. Head followed by 3, that's my third option. And finally for the tail also we have three options. So you can get all the six outcomes using the tree diagram, or you can also make the table. Any which ways, this event is called an independent event. Why independent? Because here the outcome of the first event, which was the tossing of the coin, no way it affects the number that will come on the spinner. So the outcome of one event is independent of the outcomes of the other event, or it is not affected. So if we read here, independent events are two or more events with the outcome of one event does not affect the outcome of the other events. They are completely disconnected. One is the tossing of the coin, one is the moving of the spinner, no connection at all. So this is an example of independent event. Now, to find the probability of independent events, as you just see here, we are just doing the multiplication rule. So in the next slide now, I will explain you how the probability can be found by multiplying the probabilities of each of the simple events. So let's see that in the next slide. Okay, so this is the very important rule that you will use, multiplication rule, to find the probability of the independent event. So if you have two events, the first event is A, the second event is B, and you know that both of them are independent, means the outcome or the probability of one event is not affecting the other. Then to find the probability of A and B together, or you can also say A intersection B. We have done intersection and union in the second lesson. Then what you do, you take the individual probabilities of both the events A and B, the first and the second event, just multiply. That is the rule. So this rule can be it can be done for 2 events, it can be done for 3 events, it can be done for 4 events, but I think in your grade 10 you'll just deal with maximum of a 3 event. So just remember, when you know that the 2 events are independent, first you check whether they're independent or no, and then just do the product or multiply the individual probability to get your answer. So let's take an example in the next slide. Okay, now let's see an example of independent event. So there's a girl, Anna. She's a member of a gaming website and she is randomly pairing users to solve the puzzles. Now there are a total of 50 other players which are currently online, and out of those 50, Anna is only friends with 10 of them. She knows them. She is being friends with them, but the remaining 40, they are unknown to her. They are like strangers and she doesn't know. Now, suppose Anna is paired. So look at the situation. What's happening? Suppose Anna is paired with a player for a game, not liking the outcome. Maybe she got somebody who she doesn't know or she's not friends with. So she doesn't feel the connection and she disconnects. And then she's paired with another player randomly. This is all random happening of the pairing. Now, in part A, you need to do the probability that neither the player that she selects, maybe she selects 2 players, the first one, and then she doesn't like because maybe she's not connected, she's not friends, then she chooses another one. But you need to find for this part the probability that both the players that she chooses is not her friend. If you read the question once more, what is the probability that neither player that Anna is paired with is a friend of hers? So that means she's paired both times with somebody she doesn't know, who she's not friend with. So that means out of this 50, she is paired with the remaining 40. Anybody? Now think, are these 2 events the first player that she's paired with and the second player that she's paired with? Is this an independent or a dependent event? Definitely it's independent, because the set of possible matches that is happening, it resets to 50 once Anna disconnects. It's not that, once a player is chosen, it cannot be chosen again. It's not that. So it's without, it is with replacement. Okay, so this is, I will write with replacement. Okay, so the total number does not change. The total is reset to 50 every time she disconnects. So let F, capital F, represent a player who is her friend, and capital NF represents a player who is not her friend. So these are just like symbols that we use. So let's find the formula for probability of the independent event, and definitely I'm using this time multiplication rule. The first time she's paired and it's not a friend, it can be any one of the 40, because there is total 50, out of which 10 are friends, 40 are not friends. So we are choosing this one, not friends. So favorable outcome is 40, total outcome is 50. So this will be the probability. I'm using the basic formula for probability, which I've taught you many times before, that the probability of an event is number of favorable outcomes divided by number of total outcome. So we divide that. So each time the probability is same. First time 40 over 50, second time 40 over 50. Why? Because it's independent. So now just multiply, simplify on your calculator, and the fraction that you get is 16 over 25. Now you can also convert this to decimal, or you can convert it to fraction. All are going to be the same answer. So if I divide 16 with 25, this fraction converts to the decimal 0.64, and if I want to just convert to percentage, multiply by 100, and what you get is 64%. All three are correct answer. Now part B asks you for the assumption. Definitely the assumption that we make here is that it is without replacement, first of all. Also, we assume that the same 50 players remain in the set for both the selections. There is no player who is changed. And once she chooses a player and she, disconnects, she doesn't like, then that player goes back into those 50 number. So this is the assumption. Let's read together. If the number of available player changes, or the number of available players who are friends with Anna changes, the probability will definitely change, and then it will no longer be independent. So we have to make the assumption that the same 50 players are chosen and there is no change whatsoever. Now let's solve a check question. So in this, Paula's weather app is checking what is the percentage of rain. So there are 2 days. One is Tuesday, one is Wednesday. The probability that it's going to rain on a Tuesday is 20%, and the probability that it's going to rain on a Wednesday is 50%. The question is asking you what is the probability that it will rain on both Tuesday and Wednesday. Now these are independent events. It's very, very clear because the probability that it will rain on Tuesday is no way connected. It is no way affecting the probability that it's gonna rain on Wednesday. The outcomes are completely disconnected. So we are going to use definitely the multiplication rule here that I have explained to you to get your answer, because both raining on Tuesday and Wednesday are independent events. So just multiply the two probabilities. Now these are given in percentage, you can convert to fraction. But because in the question the answer was given in percentage, the final answer I'm going to give as a percentage. Okay, so now do some cancellation. 0 0, all of this is done. 2 multiplied by 5 is 10 over 100, so this is nothing but 10%. So the chances that it's going to rain on both Tuesday and Wednesday is 10%, or if you want to convert to fraction, it's going to be 1 over 10. So easy. So that is all today for the first part of this video, where we have understood independent events. In the next video, I will show part 2, which is dependent events. So stay glued and make sure you subscribe to the channel. Let me know in the comments if this video was useful for you and which more videos of the topics of probability I should make for you. Until then, this is Ms. Ruchika signing off from today's session. Wish all my great and advanced students all the best for math exam.